We have solved some example on new topic. So anyone remembers that topic name? Yes or no? Please on your mic. I'm audible. Yes. No one. So I have shared some slide with you now. So there is an example. So can you remember now that what is the topic name?
Minimization of finite automata.
Correct. So within so when we
Sir,
consider the yes. So within this minimization of finite automata, so anyone remembers that what is the aim of this minimization? Why we need to minimize the finite automata? We have discussed about this within the last session. So anyone remembers about that? Minimization of finite automata means what? What you are going to minimize within this process? Please reply fast.
Number of states.
Number of state. So whenever we are preparing a finite automata for any purpose, for any machine designing purpose, so at that time, if due to some limitation, we need to minimize the number of states. So how to minimize that number of states? So there is a procedure that is labeled as minimization of finite automata, and with the help of these steps, we are going to minimize the number of finite states. So here within this problem statement, either a diagram is given to you, that is a transition diagram, or a transition table is provided. And using this transition table or a diagram, you have to minimize the given finite automata. Okay. And most probably it is a deterministic finite automata. Up till now, whatever is the example we have considered. So if you remember these examples, so all these examples are the of deterministic finite automata. Clear? So anyone remember the step number 1? So what is the step number 1? How to minimize this finite automata? There are certain steps. So anyone remember about this?
finding pi 0.
Yes, but how we are going to find out that pi 0?
We will group in final and non-final state.
Okay. So yes, let's start with the pi 0 now. pi 0. So within this pi 0, we have to separate the final and non-final state. So final state within this table, it is represented with the circle, that is a Q5. So we will write down Q5 here within the one set, and remaining all non-final states are written within the another set within the pi 0. So Q0, Q1, Q2, Q3, and Q4 are within the one set. Okay. The next pi 1 we have to find out. So how we are going to find out the pi 1? Anyone remember about this? How to prepare this pi 1? Please reply.
By checking the equivalency of Q0 with all other states.
Correct. So here we have two sets, that is set of finite state and set of non-finite states. So if you observe within this set, that is a set of finite states, there is only one element. So we cannot partition this set, but within the set of non-finite states, within this set, there are number of states, and we have to check the equivalency between them. That is, Q0 is equivalent with Q1, Q0 is equivalent with Q2, Q0 is equivalent with Q3, and then Q0 is equivalent with Q4 or not. This thing we have to check. And then we have to prepare the set like this, that is Q5 as it is here. Then next we have to find out the set of states which are equivalent with the Q0. So how we are going to check the equivalence? So that equivalence is checked in such a way that is Q0 is checked with the all other states. That is Q0 is checked with the Q2, sorry Q1, then Q2, then Q3, and similarly with the Q4. Not with the Q5, because Q5 is the final states and it is in the another set. So this Q0 equivalence is not checked with the Q5. This thing you have to remember, that Q0 is not checked for the equivalence with the Q5, only with the states which are present within the same set, where that Q0 is going to reside in the pi 0. So we will check the equivalence of Q0 with the Q1, Q2, Q3, and Q4. So how we are going to check that? We have to find out its transitions from the given transition table. So how we are going to find out that? So what are the inputs A and B? So Q0 with input A, that is Q1. So Q1 we will write down here. Q0 with input B, that is Q2. So we will write down Q2 here. Then Q1 with input A, Q1 with input A, transition is Q1. Again Q1 with input B, transition is Q3. Here we write down Q3. Now we need to check the equivalence of Q0 with the Q1. So we need to check that Q0 with input A, there is a transition towards Q1. Again Q1 with input A, there is a transition towards Q1. So it is only one state and it is in the set of non-final states. Next we will check that Q0 with input B. So Q0 with input B, it is on Q2, and Q1 with input B, it is on Q3. So Q2 and Q3 are within the one set, that we have to check. So Q2 is present here and Q3 is present here, means within the one set. So when these elements are appearing within the one set, then this state, this present state, that is the Q0 and Q1 are equivalent. Understood? When the states are equivalent, when the transitions on the single input, that is Q0 with input B, Q2, Q1 with input B, Q3, then Q2 and Q3 are within the one set, then they are said to be a equivalent. Then Q0 is equivalent with the Q1. Next, we have to check the Q0 equivalence with the Q2. So we just remove this now. Q2, then next Q2 with input A, Q2 with input A, transition is on Q3. So here we have to write down Q3. Next, Q2 with input B, transition is on Q4. So Q4 is here. Now we have to check the equivalence of Q0 with the Q2. So we will check that Q1 and this Q3 are within the one set or not. So Q1 is here and Q3 is also within the same set. So they are equivalent. Next, 2 and 4. So 2 is within this set and again 4 is also within the same set. So both the transitions for input A and B for Q0 and Q2 respectively are within the one set. So they are equivalent. So I am going to write down here Q2 also. Q2 also. Okay. Understood now? Let's check for the Q3. So Q3 with input A, transition is on Q1. Q3 with input B, transition is on Q5. Now we will check the Q0 equivalence with the Q3. So Q0, Q0, same state, it is obviously within the one set. Q2, Q5. So Q2 is available here. I am just going to change the color now. Q2 is here, then Q5 is within the another set. So they are not equivalent. So this Q2 and Q3 are not equivalent. Next, we have to check the equivalence of Q0 with the Q4. What is the transition of the Q4? Q4 with input A, it is on itself. In Q4 with input B, it is on Q2. So Q0 with input A, it is on Q1, and for Q4, it is on Q4. So 1 and 4. So 1 and 4 are within the one set. And 2, Q2, Q2. So Q2, Q2 is the same state, so it will reside within the one set. So Q0 and Q4 are also equivalent. And Q4 are also equivalent. So which state is remaining now? Can you please tell me? Which state is remaining from this set of non-finite states?
Q3.
Q3. So we'll write down that Q3 in the last, in a separate set. So we'll write down that Q3 here. Next, we have to prepare the pi 2. And when you are preparing the pi 2, you have to look into the pi 1. Okay? So Q5 as it is first. So within Q2, Q5 is as it is because there is no need to partition because that set is consist of only one element. Next, Q3 is also as it is. Q3 is also as it is, this Q3. We have to just check the equivalence of Q0 with the Q1, with the Q2, and with the Q4, with these three states now. Okay, so let's check that equivalence now. We will check it now. With Q1, with Q2, and with Q4. So student, now we have to check the equivalence of Q0 with the Q1, Q2 and Q4. So when we are preparing the pi 2, we have to check into the pi 1. This thing you must remember. So Q0 is checked with the Q1 now. So Q1, it is a one state, so obviously it is within the one set. Q2, Q3. So if you observe, Q2 is here and Q3 is here within the different sets. So they are not equivalent. So Q0 is not equivalent with the Q1. So Q0 will be checked with the next state, that is a Q2. So 1 and 3. 1 and 3 within the one set? No, they are within the different sets. So no need to check further. They are not equivalent. You can directly say. The next Q0 is checked with the Q4. 1 and 4. 1 and 4 within the one set. 1, this 1 and 4 within the one set. The next Q2 and Q2. One state, so obviously it is within the one set only. It is a single state, Q2, Q2. So it will remain within the one set. So don't worry about that. Okay. So Q0 is equivalent with the Q4. So if you observe Q0 with input A, it is Q1 here, this Q1. And here Q0 with input A, it is a Q4. So 1 and 4. 1 and 4 within the one set, 1 and 4 within the one set, 1 and 4 within the one set. And this Q2 and this Q2 is a one state. So it is within this set. So here we can write down that Q0 is now equivalent with the Q4. Now from this fourth state, 1 and 2 is remaining. So we have to check that 1 and 2 are equivalent with each other or not. A and B. What are the conditions? 1, 3, 3, 4. So let's move on to the remaining notations. So here Q1 with input A, Q1 is here, Q2 with input A, Q3. So Q1 and Q3 within the one set, Q1 and Q3 within the different set. Okay, so they are not equivalent here. So as they are not equivalent, we have to write down them separately. Q1 and Q2. We have to write down them separately. Okay, and then we have to close the set. Understood that why they are not equivalent? Because this 1 and 3 are within the different sets, so no need to check further, because we want the equivalency for all the inputs, not for the single input. Clear? If you have not understood anything, then please ask me now. So here we close this set now. Next we have to prepare this opening bracket, and it is the closing curly bracket, and these are the elements of our pi2 set. Now we have to prepare the pi3, and when we are going to prepare the pi3, we have to observe the pi2. So all the set which include single element, that we will return in the starting position. So Q2, Q3, then Q1, Q2. Now the remaining is Q0 and Q4. We have to check here also now that Q0 and Q4 are still equivalent to each other or not. When we are preparing for the pi3, we have to look into the pi2. Clear? So what is the transition of Q0 with input A? Q0 with input A, it is on Q1. Q0 with input B, it is on Q2. Q4 with input A is on Q4, that is itself. Next, Q4 with input B is on Q2. Now if you observe here, Q0, Q4 is having the transition for input A, that is a Q1 and Q4. So if you observe here, within the pi2, Q1 and Q4 are within the different set. Q1 is here, Q1 is here, and Q4 is here. So they are not equivalent now for the pi3. So we will write down them here, Q0, Q4 separately. Sorry. Q0 and here we write down Q4. So here you can observe that within the pi3 we are going to obtain the states as it is, that is all states are separated as it is, means whatever is the states provided within the initial finite automata, that is from Q0 up to the Q5. So total number of states are 6. So similar 6 states we are going to obtain here within the pi3. So that may be the case. So that's why this example I have considered here, that within this example we are not going to obtain any minimized automata, because here number of states are same, and this pi3 cannot be classified further, or we can say it cannot be splitted further. So we can write down here that is pi 3 is equals to pi 4 or pi 4 is equals to pi 3, and then we can stop. So here also total number of states are 6, and here also the total number of states are 6. Clear? So please try to understand this, that there may be a scenario that when you are using the minimization of the concept of minimization of finite automata, there may be a case that no any particular state is going to be removed. Means all the states will remain as it is, as here, like 6 states within the original table and 6 states within the minimized table. That is, both are same. That minimization is not done for that particular example. So any doubt within this, students?
No, sir.
So are you able to solve this kind of examples?
Yes, sir.
So let us consider this new example and just tell me the pi 0 value, or we can say the elements in the pi 0. Any one of you? Student, please reply fast. You can write down your answer in the chat box also. No problem. So student, please reply fast. Our time is running out. So how many finite states here?
Q3 and Q4.
Q3 and Q4. Correct. And remaining all are the non-finite states. Q0, Q1, Q2, then Q5, then Q6, and Q7. So what is the content of phi 1 now? What is the content of phi 1 now? First check that Q3 and Q4 are equivalent or not. Because this final set of finite states is consisting of more than one state now. So here we can check that equivalence. What is the transition of Q3? That is with input A it is on Q5 and with input B it is on Q6. Next for Q4. So Q4 input A. So they are equivalent or not? Can anyone tell me? They are still equivalent or not? Should I write down here Q4 also? Q3, Q4, 06, 57. So just check out this answer. So Q3 and Q4 are equivalent, no issue. Why? Because 5 and 7. So 5 and 7 within the one set, then 6, 6 it is within one set. So Q3 and Q4 are still equivalent, and now we have to check that Q0 is equivalent with 1, 2, that is this thing, that Q0 is equivalent with Q1 or not, Q0 is equivalent with Q2 or not, and Q0 is equivalent with Q5 or not, Q0 is equivalent with Q6 or not, and similarly for the Q7. So everyone agreed upon this answer? So just tell me the value of pi 2 now. Or can anyone tell me that how many number of states we are going to obtain in the last out of this? Means here total 8 states are given. We are going to minimize it up to less than 8. So that less than 8 is either 7, 6 or 5. Can anyone please tell me? 7, 6 or 5. Up to what extent we have minimized it? 7, number of 7 states or 6 states or 5 states. So no doubt student. So we need to stop the session here. So please complete this example because our time is over now. So please try to remember that whenever there is a minimization of finite automata, so two things we have explored today, that there can be a situation that we are going to obtain the same number of states as like in the given finite automata, means minimization is not done. Second thing, we have to consider the finite states, there is more than one finite states, and these finite states most probably remain equivalent throughout all the pi 0, pi 1, pi 2, pi 3. Okay, so please remember this thing. So anyone minimize this finite automata? Can anyone please tell me the answer that how many states you have minimized?
5 states.
Up to 5 states. Okay.
Yes.
So from 8 states, we have minimized it up to the 5 states. So can you give me the last answer? It is pi 2 or pi 3?
Sir, pi 2.
Pi 2 means pi 2 is equivalent with pi 3.
Yes.
Pi 2 is equivalent with pi 3. So here last is a pi 3. So means we are going reverse. That pi 3 is equivalent with pi 2. So you need to stop. Clear? So pi 3 is equivalent with the pi 2. Clear? So write down the pi 3 answer now. Pi 2 answer is provided by one student, roll number 152. So provide the pi 3 answer now fast. Please write it down. Our session time is over. So please write it down fast.
Would be the same as pi 2.
Okay. So one student just discussed with me that pi 3 is okay. Actually. So here we can say that pi 3 is equals to pi 2. Pi 3 is equals to pi 2. So we need to stop. Yeah. So please remember this thing. So we close the session now. If you have any doubt, then please post the message in the chat box. Okay. So here we have near about we have completed our first unit. We will check out within the next session. If there is anything remaining, then we will complete that and then we move towards the next unit now. Okay.